Hi everyone, it's another video. Welcome back. In this video, we're going to talk about another topic in chemistry from junior side. We're going to look at elements and the periodic table. In this video, we expect to discuss a lot based on the elements as well as the periodic table. Um, we already have background from Form 1 where we looked at the periodic table and some of the elements. But here we're going to look into details about elements as well as the periodic table in general. So let us start by looking at the success criteria that we are supposed to cover by the end of this topic. So by the end of this topic, we should be able to describe the patterns in properties of elements in the periodic table, should be able to identify blocks of elements in the periodic table, such as metals, metalloids, nonmetals. We'll be able to discuss the trends in the periodic table in terms of atomic um, radius. We're supposed to discuss the trends in terms of atomic radius. So let us start by looking at blocks of elements in the periodic table. As I already alluded in the previous slide, we have blocks of elements in the periodic table. So in details, which ones are the blocks of elements in the periodic table? So we have three major blocks of elements in the periodic table. We have the metals, we have non-metal elements, we have metalloids, and metalloids sometimes they are known as semi-metals. The metalloids have a similar behavior of either a metal and non-metal. We also have transition metals, which are also known as heavy metals. So these are the blocks of elements in the periodic table. So the question might be, why are we writing three blocks of elements in the periodic table, but here we have written four? Remember, on the transition element, transition metals or transition elements, they are still metals, but these ones are heavy metals. That's why we are calling it as transition metals. Examples of metal elements in the periodic table for the first 20 elements. Remember, in junior section, we usually focus on the first 20 elements that we discuss. A small periodic table of 20 elements. So in those first 20 elements, examples of metals, we have lithium, and the chemical symbol of lithium is this one. We have sodium, and the chemical symbol is Na. Remember, when we are writing the symbol which will represent the element in a periodic table or in a chemical reaction, we use the first either the first letter or the first two letters. It depends as well. But here we have sodium. Sodium, remember, when we're writing the chemical symbol, we're using a Greek, we're using another name, that is natrium. Well, that's why here there is Na. So we have potassium, which the chemical symbol is K. We have beryllium, which is Be. We have magnesium, that is Mg. We have calcium as well as aluminium. So these are examples of metals only for the first 20 elements. Remember, we have a big periodic table which comprises of 150 elements, but for the junior section, we are supposed only to cover only the first 20 elements. That's based on our syllabus. So examples of metals are these. So in short, it means we have 7 metals in the first 20 elements of the periodic table. Examples of metalloids. Remember, metalloids I also said they are some metals. They have similar properties of either a metal or a non-metal. We have 2 in the first 20 elements. We have boron as well as silicon. Boron is in group 3, while silicon is in group 4. Examples of non-metal elements in the periodic table for the first 20 elements. So it means if we subtract metals and metalloids, the remaining ones are non-metal elements. So we have hydrogen, carbon, nitrogen, phosphorus, oxygen, as well as sulfur, we have fluorine, we have chlorine, we have helium, we have neon, we have argon. So these are examples of nonmetal elements which are found in the first 20 elements. Now, let us have a look at a periodic table. So as I said, for the first 20 elements, it means we have specific elements which are found there. For example, if this is group number 1, this is group number 2, and in the first slide, when we were talking about blocks of elements, we said we have transition metals. Now, on this big periodic table is where we can demonstrate and show which ones are transition metals, which are also known as heavy metals. So starting from this one, from here, all these are transition metals, including all these ones. They are all transition elements or transition metals. Remember, for the first 20 elements, it means we can have hydrogen, lithium, sodium, and potassium. In group 2, we have beryllium, magnesium, and calcium. In group 3, we have boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, as well as argon. These are for the first 20 elements, and those ones are the ones which are recommended in our syllabus for the junior section. So this is how a periodic table look like. It complies now all the 150 elements in it. The general periodic trends now. We will shift from blocks. We are going to start looking at the trends which are there in the periodic table. So the major trends which are there in the periodic table include the following. The first one, an atomic radius, ionization energy, electron affinity, and electron negativity. So we'll be looking at each trend in details. How is it affected in the periodic table, and what happened to each trend in the periodic table. So we'll start looking at atomic radius. In mathematics, we have an idea in mathematics how a radius look like, but now here we'll be looking at the atomic radius. It means we are going to be looking at the radius of an atom. So if we were to begin, we'll look at the definition of an atomic radius. So what is an atomic radius? So if we are to define an atomic radius, an atomic radius simply means it's a distance from the center of the nucleus of an atom to the outermost energy level. Remember in Form 1, we used to draw the structure of an atom, and we used to draw a circle to represent the structure of an atom, and sometimes we had, if we are representing the inner circles, which are called energy levels. So if we start from the center of the nucleus to the outermost energy level, it will give us a radius of that particular atom. And also we need to know the definition of an ionic radius. So we need to be very careful. Now we have changed here. We have an ionic radius, and here we have an atomic radius, but all in all we are looking at the radius. So first of all, it means we need to go back and define, and we should be able to know the word ion. So in Form 1 we learned about a neutral atom. In a neutral atom, we said it has equal number of electrons and protons, and a neutral atom does not have a charge, because the charge of positive, which are protons, and negative, which are electrons, cancels one another. And an atom can be charged. For it to be stable, it's either can be positively charged or negatively charged. So when an atom is charged, is known as an ion. When it loses the electron, it becomes positively charged, and when it gains the electrons, becomes negatively charged. Such charged atoms ions, they are known as an ion. So let us define an ionic radius. So An ionic radius simply means it's the distance from the center of the nucleus of an ion to the outermost energy level or shell of an ion. So that is the difference between um, ionic radius and atomic radius. So sometimes questions do come, can you differentiate between an ionic radius as well as an atomic radius? So in an atomic radius, we are looking at a neutral atom where number of protons are equal to the number of electrons, while in an ionic radius, we are looking at a charged atom where the number of electrons and protons are not the same. So this is a diagram showing an atomic radius. So as we said in the definition, we said it is a distance from the center of the nucleus of an atom to the outermost energy level. So let us assume in this diagram, this is an atom and here we have a nucleus. So from the center of the nucleus to the outermost energy level, so the distance in between here is known as atomic radius. It's known as an atomic radius. So factors that affect the size of an atomic radius. Here we need to understand one another, because when we are talking about trend, we will be looking at the different elements have different atomic radius. So we'll be discussing much on the factors which affect the size of an atom, why atoms have different atomic radiuses. So the first one is the number of energy level, and the second one is shielding or screening effect. So we need to go into details on how these affect the size of an atom. So when an atom has many energy levels, the size of an atomic radius increases. This is true. As you are adding the circles, it means now the size of an energy level is increasing. What makes the energy level to be increasing? It depends now on the number of electrons an atom has. So if an atom has many electrons, we expect to have many energy levels, because each energy level has specific number of electrons that it can hold. If we look at the shielding effect, or it is also known as screening effect. Okay, let us define this word firstly. What is a shielding effect, or what is screening effect? So shielding or screening effect refers to the reduced attraction by the nucleus for the outermost electrons. Reduced attraction by the nucleus for the outermost electrons. So what causes the reduction in the attraction by the nucleus to the outermost electron? It is caused by inner electrons which are found in inner energy levels. So here it's very important to understand shielding effect, because if we don't understand about shielding effect, it will be very difficult in other explanations that are coming. If we are to look at how the changes in the size of an atom are close as well as moving from top to bottom of the periodic table. So we have defined shielding effect as a reduced attraction by the nuclear charge to the outermost electrons which are found in the outermost energy level. So this is caused by inner electrons which are found in inner energy levels. So here we have a diagram. When, for example, we were talking about a nuclear charge. A nuclear charge simply means it's a positive charge which is created by positive protons which are found inside the nucleus. Remember, these two things, these particles have different charges. Protons have positively charged, while electrons which are found in energy levels, they have negatively charged. So as they are revolved and they are held by the nuclear charge, which is offered by the nucleus. Remember, opposite charge are going to get attracted. So this is a demonstration on how shielding occurs. So remember, electrons do not just sit idle in the energy levels, they are always revolving. So as they are revolving, we expect as the attraction which is offered by the nucleus to the outermost energy level, blocked by these electrons which are going to be moved, will be moving close here. So if you have many energy level, it means the attraction will be reduced, because as the electrons are moving in the energy levels, we expect to be getting more attracted to the nucleus, it means it reduces the attraction which is going to be offered to the electron which is found in the outermost energy level. Another thing on shielding, we can talk about repulsion. Repulsion means it means there is an opposite charge which they are separating amongst the electrons. Remember, the electrons have negative charge. So if it is negatively charged here and the other one is negatively charged here, we expect that they are going to repel because the same charges do not attract, but they are going to repel. So if they repel, we expect that the outermost energy level will still move out a little bit, extending the size of an atomic radius. So let us sum up what happens in those particular diagram. Inner electrons shield outermost electrons for the nuclear pool. It means as they are revolving, they block the attraction, full attraction that is going to be offered or was supposed to be offered to the electrons which are found in the outermost shell. By doing so, this causes mutual repulsion between inner as well as outermost electrons. I've said repulsion comes in as well because of the same charges. Same charges do not attract one another. So the greater the shielding effect, the easier to remove an electron, since the outermost electron will be not muchly attracted to the nucleus, it is easy to be removed. The repulsion of electron causes the size of an atom to increase. How does that one work? We have said that if they have the same charge, it means they are going to repel. If they are going to repel, it means the outermost energy level will be extended outward. So if it is extended outward, it means the size of the atomic radius now increases. So we need to look at the definition of nuclear charge because we have been talking about a nuclear charge. What is it all about? So a nuclear charge is a positive charge created by protons inside the nucleus, which holds the electrons in the energy level. That is the definition of nuclear charge. So how does shielding now affect the atomic radius? When the number of electrons in inner energy levels increases, simply means maybe you have higher atomic number, it means you have more electrons. So it means you are going to have a lot of energy levels. So in those energy levels, we are going to have electrons. That's why we are saying that when number of electrons increases, more energy levels will be developed. So the electrons in inner energy level block the attraction offered to the electrons in the outermost energy level. This makes the energy level, the outermost energy level, to extend outward, increasing the size of the atomic radius. This is how shielding affects the size of an atom. So what happened to atomic radius as we move down the group? Not only the group, all groups of the periodic table. So as we are moving down the group, we can know that we already know that the atomic number is increasing. So it means as the atomic number is increasing, likely the atomic radius will also increase due to the following factor. First of all, number of energy levels. As we are going down, the number of energy levels are increasing. We expect the atomic radius also to increase. The second factor that affects the size of an atom as we are going down the group is shielding effect. Going down the group, number of electrons is increasing. This means the electrons in inner energy level block the attraction offered to the electrons in the outermost shell. This makes the electrons in the outermost shell to be weakly attracted by the nuclear charge, and there will be also repulsion between the inner electrons and the outermost electron, extending the size of an atom. Therefore, moving from top to bottom, the size of an atom increases. This makes the atomic radius to increase. So a question can come, explain what happens to the atomic radius as we are moving from top to bottom. So the answer would be, moving from top to bottom, the size of an atomic radius increases. Why? What makes the size of an atom to increase? First of all, is because as we are going down, the number of energy level is increasing. as the number of energy level increases, it means the inner electron block the attraction offered to the electrons which are going to be found in the outermost energy level, as well as there will be repulsion between inner electrons and the outermost electron. Therefore, the outermost energy level will be pulled outward, extending as well as increasing the size of an atom. So let us look at the examples for group 1 elements. In group 1 elements, we have, for the first 20 elements, we have lithium, sodium, and potassium. Why have we left hydrogen? Hydrogen usually is found in that part because it has one electron in the outermost shell, but it belongs to non-metal. So here, when we're referring to group 1, we're only focusing on metals. So we have lithium, sodium, and potassium. So this is what we were saying. If you check here, we have 2 electrons inside and 1 electron in the outermost energy level. As you are going to look properly, it means this one has 3 electrons. And it means inside the nucleus, there are also 3 protons. If we go down here, you are going to see that the number now of energy levels have been extended due to increase in the number of electrons. Remember, I said each energy level occupies maximum number of electrons that is supposed to be occupied. So if you go here again, number of energy level increases. So the first factor that extends the atomic radius is the number of electrons. If it has more electrons, it means you are going to have many energy levels. So moving from top to bottom, the number of electrons are increasing. It means you are going to have many energy levels. That's why you see the atomic radius is increasing. And the other one is shielding. If you check here, this one is shielded by 2 electrons. This electron is shielded by these 2 electrons as it is revolving around the energy level. It shields the attraction. But what about this one? This one is shielded by almost 10 electrons inside. So we expect the attraction force to be blocked, and there will be a repulsion between this one and this one as they are revolving. This extends the size of the atom. Same applies to potassium. So what happens to atomic radius as we move across the periods? Across means from left to right now. Moving across the period, what happens? The number of energy level remain the same. Remember, in the periods, elements which are found in the same periods have the same number of energy level. But what happened now? You are adding electrons in the same energy level because the energy levels are constant. So as we are moving across, the energy levels are constant. We are adding electrons in the same energy level. The electrons are filled in the same energy level. This means there is less shielding. So that means the shielding which is there in group number, period number, for example, if we are going to take period number 1, group number 1 up to group number 8 or 7, they are going to experience the same shielding because in inner energy level, they are going to have 2 electrons. So the shielding effect is also less and is constant amongst the elements in the same period. So at the same time, moving across, number of protons are increasing. If the number of protons are increasing, it means now the nuclear charge increases its strength. So if the nuclear charge increases its strength, it means the outermost electrons are going to be strongly attracted because the nuclear charge now is more strong. So hence, moving across the periodic table from left to right, the nuclear charge is very strong. It attracts the outermost electrons so strongly. Therefore, the outermost energy level is pulled inward, reducing the size of the atomic radius. We can see from the diagram here, we have a periodic table showing the atomic radius. So we'll focus much when moving across. Moving across, I said we are starting from left to right. So you can check here. This is lithium, we have beryllium, we have boron, we have carbon, we have nitrogen, we have oxygen, we have fluorine, we have neon. So as we are going across here, the number of energy level is the same. What is the difference is now number of electrons. Here we have 3, here we have 4, we have 5, up to 10 here. It means the same number of protons. Here we have 3, we have 4, we have 5, we have 6. So if we are going from left to right, the nuclear charge is increasing. It means the outermost electrons are going to be more attracted here comparing to this one. So if it is more attracted, the outermost energy level is pulled inward, reducing the size of the atomic radius. So note, when an atom gains an electron, the atomic radius increases. Why is it like that? If it gains an electron, it means now the nuclear charge is further reduced in attraction to attract the incoming electron. So there is also high shielding if you are adding another electron. But when it loses an electron, it means now we are liberating some of the force that was there to attract the electron which has moved out. Therefore, it means the nuclear charge extends its strength a little bit, attracting the remaining electrons, and the atomic radius decreases. Now we have a bar session. Bar session, a quick exercise where we need to check ourselves in terms of understanding. So the first one is define the following terms as used in chemistry. We have atomic radius, ionic radius, shielding effect. We need to try to define these terms. The second one, explain why atomic radius increases moving down the group in the periodic table. The third one, explain why the atomic radius decreases moving across the period. Question number 4, given the following species, sodium, a neutral atom of sodium, and a charged atom of sodium, which one has the long atomic radius? Explain your choice. Given the following species, we have a neutral chlorine atom and a charged, negatively charged chlorine atom. Which one has the long atomic radius? Explain your choice. How does core electrons affect the size of the atomic radius? So this is question number 6. That's the end of the bar session. For more information, we have the sources that we are using to prepare the presentation. We have Excel and Succeed Junior Chemistry Book 2. We have Achievers in Chemistry Book 2, Target Chemistry Book 2. We can use these resources to extend and expand much of the knowledge which has been shared in the presentation. For further checking as well, the photos that have been used, these are the links that we can click to find out more about the photos and maybe look at more about the photos. This marks the end of this presentation. Goodbye.